I'm not seeing the room or speak the room or camera. What's going on with that?
Hello, I'm here.
Hello. Okay, I think we're ready to get started.
Yes, we can start, I think.
Great. Okay, well, welcome everyone to the PEARG session at IETF 122. Hope everybody's enjoying themselves there in Bangkok. I'd like to welcome today, before we get started, a new co-chair of the research group, which is Alison Mankin. We're very happy to have her with us. Unfortunately, we are both remote today, but we do have Dirk in the room who will jump in and solve any immediate issues. Thank you for being there, Dirk.
Yes, no problem.
Okay. As always, please read and digest the note well and familiarise yourself with all the relevant documentation there. And as always, note really, really well regarding the expected conduct within an RG meeting at the IETF, and also be aware that should you need it, you can reach out to the Ombudsman team to discuss any issues you may be having. General meeting tips. Please, those in the room, make sure you are signed in on Meet Eto Lite so that we have accurate blue sheets. Please join the queue if you need to ask a question, the electronic queue. General resources for the meeting and our agenda, which we will just take a few minutes to review. Do we have a minute taker today? If I can appeal for that while we discuss the agenda. We will start today with a very brief update on our active draft, which is the guidelines for performing safe measurement. Due to some scheduling issues, unfortunately, we weren't able to secure a second talk for our slot today, which means we have lots of time for the one talk that we have, which is a very interesting talk on authentication in MLS and its variants. However, we may be left with, depending on where we land, we may be left with a little bit of time at the end. And as Alison indicated on her message to the mailing list, we may take this opportunity to just have a very brief open mic with a question about future directions for research for the group itself. So I'll leave that as a question for people to mull over while we work through the rest of the agenda. Can I make one last appeal for a note taker before we move forward? Do we have anybody willing? Okay.
So it's a very light task. You just have to record the... Okay, thank you. We have one.
Beautiful. Yeah. Thank you. Okay, I see a message from Gershabad asking if we can delay the draft update to after the presentation, just so that he can get his client working properly. I feel your pain. Yep, of course we can do that. So in that case, without further ado, we will move on to the main feature, which is our presentation by Kitaro Hashimoto. Let me pull up that slide deck. Okay. Okay, And I believe the trick now is to give the control to the slide clicker bot
Yes, that would be great.
for in-room control, which hopefully has now happened.
Oh, okay. Can I start the presentation?
Yep, please go ahead.
Okay.
Yeah, please do your introduction too. We'd appreciate that. Thank you.
Yeah, okay. Okay, it's okay. So, thank you for the introduction. So, I'm Keitaro from Japan. So, and thank you for this opportunity to present our result on this IETF PRG working group. So today I will explain the how MLS authenticator messages and introduce our result about regarding this authentication in MLS. So this is joint work with Shuichi Katsumata and Thomas Prest and Guillaume Pascal Perez. First, I briefly introduce the secure group messaging. Today, these secure messaging apps are used worldwide. This data is a bit old, but so many users use the secure group messaging applications like Signal or Line or Telegram, Viber, and etc. The reason people use this secure group messaging app is for the security of the communications due to some like Snowden error. Due to some, for example, this the prison program and the U.S. government collects the users' information of this Cambridge Analytica incident. So people more and more care about the security or privacy of the communication in the real life. Based on this background, this IETF and the MLS was recently standardized as a secure group messaging protocol. This MLS is developed in a joint effort by academy and industry. So there are many papers about the security analysis or improvements for this MLS protocol. And also, I have some related works on it. And today I explain these two related works. The MLS offers a strong level of the forward secrecy and post-compromise security. This limits the effect by device compromise. So even if your device or your key is compromised, the data exposure is limited. So, and we can recover the... Okay,
Go ahead.
so even if your device was compromised, we can recover the secure situation by updating the key. I believe this MLS will be implemented in the real world applications, and many people use this protocol. So now let's explain the MLS. So in MLS, there are two types of messages. The first one is the handshake messages. This is a group operation affected the group state. So people can add or remove group members or update their key materials like public key or group secret key for security to improve the security. The other message is application message. Oh.
Someone's on the call overriding the microphone.
Hi, Sarah, could you please mute? And to the speaker, please try to keep your mouth about the same distance from the microphone.
Oh, okay.
So on the remote audio, you get quieter and louder.
Yeah,
Thanks.
I was just wondering if it's the speaker or the audio system, because remotely it's cutting in and out as well.
Yeah, it's hard to say, but it could be maybe any of the remote microphones. So if you could all mute yourself, that may be helpful.
Yeah.
Please go ahead.
Sorry. Okay. So I want to continue the presentation. So the second message in MLS is application messages. It consists of the actual payload, such as chat text or photo or stickers. And in the existing security analysis, some related works focuses on the confidentiality of this message. This is because the confidentiality is the fundamental goal of secure group messaging. So on the other hand, we focus on the authenticity of application messages. So let's see how MLS authenticate application messages in more details. So in MLS, each user has an individual signing key, SIG key, and the verification key VK. And also, the group members share the group secret key GSK. Then, when a user sends application messages, the user generates a signature for the application message his or she sent. And the signature is encrypted with group encryption key, ZK, derived from the group secret key. The encryption is for the confidentiality of sender data. The MLS draft says that the message, the sender data, like the identity of the sender or the signature, is encrypted for the privacy of the sender data. Then the group members convince the senders of the application messages by verifying the attached signature. So the authenticity property is also stated in this RFC document. So this signature guaranteed by this user authentication is guaranteed by the data signature on each message from sender signature key. So as a result, only since the signature is encrypted, only the group members who can decrypt this message is convince the sender. So this also encryption of the sender, encrypting the sender, ensure the privacy of the sender data, but it causes as a problem because the server cannot authenticate senders. Since the signature is encrypted, so server cannot guarantee the legitimacy of the sender. So in other words, there is no authentication against the server. This causes some denial of service attacks against groups, as described in this figure. Since the server cannot authenticate the sender of the message, so some adversary can send the garbage messages to some groups. Since the server cannot check if this sender is in the group or not, so this garbage message will be accepted by server. As a result, the user needs to download these messages and check if this is correct or not. But this increases the communication cost of group members. So we consider this is a problem on MLS, so we provide a solution to this problem. Our solution is anonymous group authentication in MLS. And the idea is use group secret key for group authentication. So since the group members share same group secret key, so they can generate a shared group signature key, ZSig key and ZV key. Then the group, once the group key is generated, one user in the group register this group verification key to the server with their group identity. Then when a user in the group sends messages, run the user and the server, the user and server run challenge response protocol like this. So the server sends a random challenge and the sender generates a signature with this group signature. By verifying this signature,
We've lost the remote audio a little bit again, I'm afraid.
Don't turn your head a lot. To just.
okay.
Yeah.
Okay. I see.
Yeah.
Thank
you.
Okay. Sorry. Thank you. So by verifying this signature, the server can check if the sender is in the group. Thanks to this solution allows the server to check if the.
I think the microphone is having an issue. Is it possible to switch?
Test. This is the room microphone. So far, it seems to be working because we're consistently hearing it in the room. But let's. This is. I'm still trying to see if this triggers like the cutting in and out. But it seems to be better. So let's switch.
The remote audio is good with that mic as well.
Oh, can you hear me? Okay. Thank you. So by using this group signature key idea, the server can check if the sender of the message is in the group or not anonymously. So this authentication process leaks no information about the sender or group members except that the user is in the group or not. As a result, the server can prevent the outsiders to send the garbage messages to the group. This is our solution to prevent the deniable service attacks against groups. However, our approach and MLS use the signatures to authenticate users or group members. But adding signature increases the communication cost and the computation cost of users. In the classical setting, the MLS use EDDS signature. Its signature size is only like 64 bytes. It is acceptable, I think. On the other hand, in post-quantum setting, the standardized MLDSS signature is 2.4 kilobytes, which is 40 times larger from EDDS signature. In addition, some data shows that the typical application message like chat text or photo or stickers has less than 100 byte data. So this overhead for message authentication in post-quantum setting is noticeable. So to authenticate the sender of this small data, we need to append 2.4 kilobytes or 4.8 kilobytes to send this data securely. We consider this is a problem on efficiency of using secure group messaging protocol. So we consider alternative and lightweight authentication method based on symmetric key primitives. Our solution is using the one-time tokens generated with one-way function, like SHA function. The idea is each member mint one-time token with one-way function. So each user samples the preimage X and computes the output Y, but like this. Here, the only sender knows the preimage X. And the output token Y are shared with the server and the other group members, like this. So the server stores that the Alice in the GID has this, generate this YA, and also group members store this information. Then when a user sends the messages, the preimage X is attached to the message. And since to bind the preimage X with the messages, the MAC key MK generated from this group secret key is used. So the sender generates the MAC tag by using this group MAC key to bind the messages and his or her ID and display images. And also, when a user sends messages, they mint the new tokens X prime and Y prime. This will be used for the next messaging. And this new token Y is sent along with the messages. By continuously process this protocol, each user can share the next token and without any pre-computation on something. Then when this message is sent to the server checks if the attached preimage is equal to the hash, the output value of this one function evaluation is equal to the stored value. By using this, since the only Alice knows this preimages, the server can commit that this is sent from Alice. Similarly, the receivers check if this equation check to check if the sender of this message. Also, by taking the MAC tag, the receiver can convince that the message is actually sent from the group members because only group member know this MAC key. This is our ideas using MAC tag one-time token to authenticate senders of the group members. However, this protocol is simple, but as you can see, this protocol is not anonymous. So we also propose the anonymous version of this protocol. The idea is similar to our previous result. So derive the additional MAC key, MK prime, from the group secret key and register it to the server. And by using this MAC key, MK prime, and MK prime is used to authenticate the group membership. Now, so in this protocol, each member means one-time tokens as in the previous protocol. But the difference is a public token Y are shared with only the group members, not the servers. Now the server only holds the MAC key MK prime, but the group members know the output value YA. This value is shared with some authenticated manner in previously. Then when a group member want to send a messages, the token is attached as in the previous protocol, but now the token is encrypted to ensure the privacy of senders. Instead of to show the group membership, the sender generates a mark tag with this MK prime. And verifying this mark tag, the server can check if the sender is in the group or not, like the signature-based solution. So this is our solution to provide anonymity and authenticity of users simultaneously with a lightweight one-time token and mark. So let's compare these protocols with the MLS solution. So in MLS, the anonymity since the signature is encrypted, the anonymity is achieved, but the MLS has no group authentication mechanism. Our first solution ensures the anonymous group authentication, but the communication cost is increased 2 times larger than MLS. And since in the PQ setting, the signature is large, we propose as a solution based on symmetric key primitive. The first one is a very simple solution, only using one-time token. This is not anonymous. But the communication size is very small, only 3 times security parameter bits. By using the mark to authenticate the group membership, we achieve the both anonymity and anonymous group authentication with only security parameter size overhead.
Hi, thank you. So may I see your slides for the anonymous scheme one more time? A previous one, I think.
Which one? This one?
Yeah, I think this one should be okay. So my question is that, okay, how? So the first signature, Sigma GID.
Yeah.
So basically is the MAC code.
A MAC, yeah.
Okay, so MK is a symmetric key, right?
Yeah.
You have some, you call it a ciphertext, right? CT means ciphertext?
Yeah, CT is the ciphertext of these data.
Okay, you generate a MAC code. But the MAC code, you call it a MAC sign, right?
What?
You call it a MAC sign, right?
MAC.
Yeah, because you use the MAC, S-I-N-G.
Yeah.
Okay. Yeah, normally we may not call it a sign. This is just a MAC. Okay.
Yeah, just MAC.
New token. X A prime, Y prime is something like you use ECDH? Or
No,
something?
yeah, just some random bit string. So.
Or MAC again, right? Oh, I see. Yeah.
Yeah. Sorry. MAC tag. Sorry. Oops. Token is generated like this.
Okay, I see. Yeah, thank you. But my question is that for this scheme, why it is anonymous? Because for the receiver, will know the second MAC is related to YA.
YA?
So it should be not anonymous. I don't understand.
You mean the protocol is not anonymous against the sender, a receiver?
Maybe I should next one.
So in this protocol is not anonymous.
This one not anonymous?
Yeah. So to make the protocol anonymous,
yeah,
we propose this one. Now the tokens are encrypted.
Yeah, this one should be anonymous, right?
Yeah, against the server.
Okay. I just did not get the point why it is anonymous here.
Why? So the purpose of this protocol is the receiver want to know who sends the message. So why is previously shared with group members?
Mhm. Oh, so maybe I should ask in another way. So here you mean anonymous is just this way. I know this message is from one registered user, but I do not know who is him, right? And but different message can be linkable, right? Because all the messages from the same user should linked by the YA, right?
Token is one-time use, so this token is never reused.
One-time user.
One-time use tokens. The token is used for different token is used for each message.
Okay. Yeah, maybe I check you later. Yeah. Okay. Yeah. Roughly, I know.
Yeah, let's discuss.
Okay.
So this new lightweight protocol has some drawback. So since we only use a symmetric key primitives, so the server can create the same value like the user. So especially on the MAC tag. So unforgeability of this two lightweight one-time token-based protocol is weaker than others. So colluding malicious server and malicious users can forge signatures. This is a difference from the public key-based approach.
Hi, Richard Barnes, MLS co-author. On the previous slide, I just want to confirm the X for group authentication is for in terms of authentication to an external party, because every message inside of the group is already, there's a membership MAC on the outside that authenticates membership within the group. I just want to kind of understand the trade-offs for the Cosmos variants here. So you clearly are sending less data for the along with the message in place of the signatures. It seems like there's some communication overhead in terms of going back and forth to the server to establish these one-time keys. Is that the right way to understand this?
So you mean how the cost to share the new tokens?
Yeah.
Yeah. So in this slide, I explained that the next token is sent by attaching the message. So when the sender sends the messages, the new token is also uploaded.
Okay, thanks.
Yeah. Yeah, I think there is another approach. For example, a user mints, for example, large T tokens previously and shares it. And so if so, we don't need to attach tokens. So we can choose how how user shares their tokens to group members. But in this slide, I show the one approach that a new token is attached with this messages. So yeah. Okay. So I will compare the concrete communication overhead per message. So the MLS, each message has one signature. So in classical setting, its size is 64 bytes. And in post-quantum setting, its size is 2.4 kilobytes. And in the first approach, using additional signature, the communication cost is 2 times larger than MLS. So on the other hand, this one-time token approach, the token is very small because the symmetry primitive is a PQ. It's secure in PQ setting. So, for example, this Cosmos, the non-anonymous approach, the overhead is only 48 byte, and the anonymous approach is overhead is 64 byte. So these new protocols offers better efficiency than existing approach. So their overhead is less than or equal to MLS with EDDSA, even if this protocol is secure against the quantum computers. However, I emphasize that these unforgeability is weaker than others. I think there is a trade-off between efficiency and security. So finally, this is the final slide. So I want to discuss the privacy and the usability stuff. So MLS considers the privacy of group membership. For example, this architecture document states that group membership is itself sensitive information, and MLS is designed to limit the amount of persistent metadata. This is why the MLS encrypts the sender information for privacy. However, some secure messaging apps implement the push notification for usability. The push notification means that when a message arrives at the server notices the intended receiver that the message is reached to the server. So in general, this push notification is useful for users, but this conflicts the privacy of group membership because the current push notification system implemented that the server knows who is the intended sender of this push notification. Because the server actively sends information to users without users' access to the server, so the server must know group members. So in the current situation, this push notification functionality is conflict with privacy of group membership. So I think this is a problem also. Can we take both words? So making push not enjoy the usability of the push notification, but also user enjoy the private communications. Oh, okay. So this is the last slide. So the summary of my talk. So we explain how to authenticate application messages in MLS, and we propose new authentication methods based on signatures or one-time token. The signature one is offers stronger security, and the one-time token-based scheme offers a better communication efficiency. Finally, I introduce the discussion point on privacy and usability. Because secure group messaging apps use a push notification, but it conflicts the privacy of group members or senders. Thank you for my talk.
Thank you very much. We have a couple of people in the queue. Please go ahead, Mutaba.
Yeah, this is Mujtaba.
Yeah.
So my question is, usually when we want to not expose who is the member of the group, we keep the DS as much as possible not aware of the members. With this way, after like a couple of messages, the DS or the server will know which clients are really a member of the group. So that would be a risk from my side. If we want to validate, then the DS like has more like conventional like ways to understand which one, because we have the AS, they can authenticate the clients, plus the DS can now have a like stored like list of the clients who can send or receive messages on that group, so we don't need all of these new shenanigans. But if you want to hide it as a normal like MLS architecture design, we want to hide that membership, but in this design we actually were leaking it. After a while the server will know which user is in the group. And for the notifications, usually for that case, for that specific case, when we don't want to leak the membership, we don't send notifications as like the way that we do now. All the clients pull all the messages, and then based on that, they like try to mimic the notification system. So I don't know why we need to introduce some overhead to fix a problem doesn't exist from my perspective at the first place.
Yeah.
Thank you.
Yeah. So yeah.
This is Richard Barnes again. So you mentioned unforgeability limitations on the previous slide. I just wanted to understand a little bit more about those. It seems like with this token scheme, if there's a sender who's sending to multiple recipients, and one of those recipients receives it before the other, the recipient that receives it first could change things about the message and replay it to the one who hasn't received it yet. Is that right?
So you mean the server, malicious server replay, or?
No, these are all group members because
group
this is a
members.
group protocol, right?
Yeah. Yeah, I see. So yeah.
So there's basically kind of this race condition. So that seems like a pretty significant limitation here because MLS uses MAX to prove that MAX or AEAD authentication to demonstrate that a message comes from within the group, and then the signatures within distinguish one sender from another and prevent members from impersonating one another. So the fact that there's this impersonation attack, if there's a race condition, means that reduces the utility of this, right? Because you have to ensure basically that everything's synchronous and nobody gets the message before anyone else. So just thought that seemed like an important bound to capture.
Yeah, thank you for your comment.
Q Meisel, Max Planck Institute for Informatics. So on the whole, not the delivery service not being able to figure out who's in a group, something that I've seen work quite well for this before is fuzzy tags. So you have something that will definitely match someone in the group and will match a few others who are not in the group. So then the delivery service can't, it can't go, oh, well, this message always ends up with these clients, so these are probably sharing a group. Are you aware of these, and do you think these could be integrated into what you've proposed?
So you mean so could you say that again? Sorry.
So a tag that will definitely match in the intended recipient and will also match some random other recipients in some way, so that a delivery service can't, it has a harder time figuring out who is a member of what group and who is communicating to who, because the delivery service, a phone or something would receive 90% of messages is actually intended for it, and 10% is extra stuff that's not actually relevant, so that can be filtered out client side. So can this be integrated into what you've proposed for the delivery service?
So yeah.
If that's difficult to answer, you can come to me later. I realize it's a complicated question.
Yeah.
Perhaps let's take that one offline, but thank you for raising the point.
Let's discuss offline. So sorry.
Okay, that's all the questions we have. Thank you once again for your talk today. And that was a great discussion. Thank you for everybody in the room as well for participating in that.
Yeah, thank you for giving this opportunity, and thank you for giving the comment for me. Thank you for everyone. Thank you.
And obviously, round of applause, please. We can continue that discussion on the mailing list as suggested, and there are some interesting comments and discussions in the chat logs as well, which we can take a look at afterwards. So seeing as we have a little time, the chairs thought what we might do is try and have a discussion around future directions for the research group. So if I can just take a second to pull up a slide, which we need to stop, take back control.
We'll leave 5 minutes at the end for Gershabad's status update, right? Because he actually is able to get it. Yeah.
Thank you. Gershabad, would you like to speak now, or do you want to do it at the end?
I can do it quickly now, if that's okay.
Okay, perfect. All right, please go ahead.
Yes. Hi, everyone. So a quick update on the RG adopted draft, that is guidelines for performing safe measurement on the internet. And I'll add a link to the chart as well. The draft aims to have some guidelines for broadly anyone who's performing network measurements or any internet measurement study, and so how to perform these experiments while respecting user safety primarily. In the last round of comments, I think the feedback was around this improving certain language where it seemed quite negative and cynical, but also around scope. I think there's a tough balance to strike here about how abstract the guidelines are and are to what scope of studies they're applicable to. And yes, we acknowledge that like largely this is written from the perspective of studies that may involve internet traffic from actual humans / internet users. And the latest update version 12, we pushed that yesterday, and I think it clarifies that scope. We've made other improvements to the draft, including incorporating feedback from others about adding more guidelines or more descriptions of guidelines from previous research on network measurement ethics, etc. And so, to me, the last update kind of addresses most of the feedback we'd already received. And if more feedback is welcome, of course, and I think I'll give it to back to the chairs to ask also. I know last time we had RG calls slightly early because there were a couple of open comments, but I think largely they've been resolved now. I will reach out to all the people who had commented on the scope to see whether they're satisfied. But I hope after that we can move to RG last call on this document as well. Thanks so much.
Okay, thank you, Gershabad. I think I'm correct that the latest version just came out yesterday, so I'm not sure everyone has had time to have a proper look at it and digest it, but I think what we'd like to certainly see is reviews of that and discussion on the list to see if it has addressed some of the concerns that were raised in the last call, that happened previously. So yeah, the chairs will write a note to the mailing list to encourage review of that version. Thank you. Okay, so let me share a slide deck and okay. Okay. So in chatting with the other co-chairs, we thought that given the opportunity to have a little bit of time today, what we might do is ask for feedback for direction on future research priorities for the group. Okay, I believe you're not seeing the slide, which is weird.
We see the slide.
Do you see it in the room?
Yeah.
Took a moment to come in.
Okay, right. So we were thinking about current environment, and we've thrown down 3 topics here. They are by no means exhaustive or indicative of what we're thinking. They're not suggestions for specific directions, but we were plucking ideas out the air to represent things that we have been aware of where we see a very fast changing landscape with regard to privacy. So, for example, in the IAB meeting earlier this week, there was discussion of the WSIS plus 20 meeting, which is a long-term strategic review of internet governance. And we were struck by the thought that we can't really take the stability of the current internet governance structure for granted, and that if there is a shift in that, the implications for privacy are very wide-ranging. Similarly, as a UK citizen, I am very aware of a current legal battle between the UK government and Apple with regard to their APB technology, which encrypts users' data in the iCloud, which has had to be disabled due to some demands from the UK government, and very interesting back and forth, if people have been following that, which is a very sort of real world interaction of politics and privacy. And similarly, post-quantum is something that we haven't really had any direct work related to it in PEARG yet, but obviously with such uncertain timelines and such a fluid landscape, it's again a very interesting topic. So we felt that in the context of all these shifting environments, were there thoughts that people had in the research group about potential future directions for research, topics for interims, or future talks that they would like to see? So we'd like to invite, if there's anybody in the room now who has thoughts, who'd like to step up to the mic on that. Otherwise, we would also like to encourage this discussion on the mailing list to try and indicate specific topics that people would like to see discussion on in future groups, in future sessions at IETF. So I'd like to open the mic if there is anybody there who would like to make a comment on general thoughts for the topics and for the research group specifically. Okay. Yeah, Nick, please go ahead.
Hi, so congratulations on publishing the censorship doc. This seems like it's related to privacy, but adjacent to privacy. I don't think that privacy and censorship are identical means. So I guess my question to the group is this a direction to do more work in this research group? Or if there's more censorship related work, would another group be appropriate for this? Maybe a new group.
So we certainly found space within our charter to support that work, and we were very happy to do it. But I've also heard other comments that there might be room within ITR, within the general, for a general research group on censorship. So maybe that's actually a question for Dirk, whether he feels it's early days, but do you have thoughts on that?
Sure. I mean, there are different options. But if you're looking, for topics to explore, or topics for next meetings, and you'd like to take it on, I think it's a totally fair option, a totally good option.
Great, thank you. Okay. Any other thoughts from the room before we potentially release you? Okay. Yep, Nick, please go ahead.
Yeah, I'm also interested in the censorship concept, given its relevance. But I do think there are other privacy areas that might be especially relevant to IETF work in the current moment. One thing that we're seeing a lot of work on is on privacy preserving techniques that rely on multi-party computation or something like that, for telemetry, for advertising, for all these things. Those proposals are interesting. There's good cryptography, etc. But there are also kind of fundamental privacy questions about what level of guarantees are we getting for people? How can we explain that to users, or what privacy are you getting from these aggregate calculations? That just seems like a research topic that will be relevant across IETF protocols and across protocols that go onto the web as well, and where we need good researchers to try to explain the implications. So as a research topic, I'm curious if there are people who want to work on that, sort of the human understanding of the cryptographic protocols we're doing for privacy preserving measurements.
Okay, great. That certainly sounds like something that we could potentially work on, because I think there are many areas where the public understanding and their expectation of what privacy means is certainly muddled, both by technology and by politics. So I think if we could take a technology-based view on that and do work on it in this group, I agree that sounds valuable. Okay, Alison, do you have any other thoughts on this?
Yeah, it strikes me that we're happy to be a home for things that are enhancements that maybe are to be introduced. So they're not quite ready to go to Cypher-G or to a particular group. So the multi-party sometimes is a little ahead of where we are in the IETF. And one of the things we might want to do is call for agenda items and open the option that we have a little bit longer of a meeting where we have some open agenda for the people who've been following us and participating in future meetings. And we also could, if people want to propose an interim on a particular theme, like where are we on attempts to reform advertising or attempts to make advertising more dangerous for everybody, from a privacy enhancements perspective only. We'd be happy to hear such proposals and come up with an agenda for that, because there's we're not developing the protocols, but we're bringing them forward so people can look at them and assess them for their potential for real world use. I think that's a reasonable picture of what we're supposed to be doing, and that's why why a censorship topic was reasonable. We're able to range a little bit widely. So we're eager to hear what else you think is pressing in this current world. And as a U.S. citizen, I also think there may be some pressing things that will come out of what's happening here as well. So.
Nick in the queue again, please go ahead.
Yeah, thanks. Again, this is Nick Doty, Center for Democracy and Technology. The other question I have on that scope is whether we want to be doing more privacy review type work with IETF standards. I know this idea has come up occasionally, but I do think it's especially important given given the current moment. A lot of the work we do at W3C is privacy reviews across specifications so that we can catch these sort of cross-cutting privacy issues on things like fingerprinting. I don't know if, I guess I'm trying to figure out from you all what the right venue is for trying to detect cross-cutting and privacy issues, or working with different IETF groups. Is this something that the research group wants to help with, or should we be looking for a separate place for trying to have some more teamwork about how we're going to do privacy reviews of protocols?
So that might be something that that Dirk could talk with the IAB about, because there's the crypto review board in Cypher-G, and these cross-cutting, more applied to IETF documents types of review have their ups and downs, but we would be happy to contribute to thinking about it, and supporting people getting there. Sarah, I stepped on you. Why don't you say what you were going to say?
No, I think that's a great point, and I'd just been reminded by that question that, and I'm not sure of the current status of this, but a while ago there were very vague discussions about creating a privacy secretariat in the same way that there are for some other topics. We have a DNS secretariat, etc. And but the last time I heard talk of that was a good while ago, so I don't know if there's still interest in doing something that formal. But again, that could be something, you know, raised up to the leadership.
You have Colin in the queue.
Hi, Colin Perkins. I think Alison said actually a lot of what I was going to say. You know, it's important to remember that the IETF and the IRTF are different organizations, and while there is certainly a long history of IETF working groups asking IRTF groups for advice on particular topics, and that can work very well, there is you know, the IRTF groups have no formal standing to give unsolicited advice to the IETF groups. So, you know, there's certainly scope for doing useful reviews, but it should be done very much in cooperation with the IETF groups.
Okay. Thanks, Colin. I see Jim Reed in the queue as well.
Thanks, Sarah. Jim Reid. I'm speaking wearing my co-chair of the DNS Directorate hat. There's a general feeling in the IETF that whenever, and I presume this also applied to the IRTF, that whenever documents have got a DNS component to them, they really should chuck them over the wall to the DNS Directorate for some kind of review. And it's better if these expert reviews start early on in the process of the document's development. So if you've got stuff that touches on the DNS, by all means, chuck it our way. We're not going to reject stuff. We're always going to be happy to receive proposals. And the sooner we can give some advice that may help the deliberations of the research group, the better.
Thanks, Jim. And I think, I mean, I guess that's general advice for early reviews of all documents with any privacy aspects in them. And whilst, as we say, all our ideas are unsolicited advice, still early unsolicited advice, it could still be very valuable in that process. So bringing a document here, you know, as it's born, is potentially useful in that context. We have Tommy in the queue, probably for the last comment. So please go ahead.
Yeah, hello, Tommy Polly, and coming up partly because IAB stuff was mentioned, and we're talking about, you know, overall structure of review here. Yeah, I agree with Colin's points that, you know, there is a distinction between IRTF, IETF. I think having a privacy directorate sounds cool. It probably wouldn't be a function of an IRTF group, but I think it's interesting to think about what are the outputs or work that this research group could do that could help inform the privacy review that happens in the IETF, be that in the form of a directorate or other things that occur during IESG review, sector review, when the IAB is looking at things going through as well. You know, there are certainly things that the IAB looks at during the time of chartering, during the time of BOFs and other points that are specific to privacy. But there could be other touch points. And I think it would be very interesting if a privacy research group like this wanted to look at, you know, researching what are we seeing in privacy considerations or problems that are coming through IETF documents? What are requirements that could exist that may be useful to take on and look at more? And that's something that could be a research document. It could be something that the IAB wants to take on. We certainly have other RFCs that we've done that are privacy related. There's room if you want to have, you know, some joint workshop around some of these things. So I think there's a lot of different angles if people have the energy and motivation to do that, that could seed information. So just throwing out some of those possibilities there.
So that sounds like a great direction. Thank you very much for that input, because I think something that probably hasn't been done is that retrospective analysis of since the privacy considerations section was brought into the RFCs, what has that generated in terms of text, in terms of changes of direction? So I love that idea. Thank you. And I just see Dirk in the queue with a comment. So please go ahead.
Yeah, I just quickly wanted to add to this. So typically the critical resource for such reviews are the people who actually have to do them. So there are, of course, different ways of organizing this, but so one way, so if like such a directorate existed, could just be, participants of this group could be members, other, IETF people could be member. I'm not so sure it's a good idea to create these organizational dependencies between some IETF directorate and research groups in the IETF. But I'm happy to discuss this more.
Okay, that's great.
Thank
We
both of our IETF chairs for joining us, and Dirk for anchoring us. We're very lucky to have two leaders today, and our speakers and the open mic participants. This has been great. Sarah, I just wanted to put in my thank yous before you do yours.
Yep, what she said, basically. Thank you very much to the speaker today, to the participants, to the chairs in the room. And we are going to look at the recording of this and take on board everything that was said in the open mic. We have a lot to chew on there. So thanks for all that feedback, and we will see you at the next meeting. Thank you very much, everybody.
See you soon. Bye.